So what Chandra's going to be talking about now is kind of a bit of an extension and a bit of a slightly different topic than Michelle. She's going to talk about another potential monitoring tool, this one using citizen science as an option for the Kimberley.
Okay, thanks for having me, you guys and everyone else, and thanks for coming. Thanks, Michelle, for that fantastic talk. There you are. Okay, I'm just going to talk about Pender Bay, and this is a joint project. So Kelly and Holly and Andrew Balls also contributed to it. The fantastic thing is I don't need to talk about this because Michelle already did that for me. What I will say is the breeding ground, again highlighting the locations that Kurt and Miss Jenner identified as high use areas, areas of high importance, and those are Camden Sound, Tasmanian Shoal / Buccaneer Archipelago, and Pender Bay. And also what I'll note is from that, there was basically a whale conservation special purpose zone that was designated in 2012 as part of the Camden Sound Marine Park. Outside of that area, however, those locations for humpback whales remain unprotected. And that includes Pender Bay, which we'll talk about today. So given the increased anthropogenic pressures in the Kimberley, particularly resource sector and tourism, increase in warming oceans and changes to primary productivity, we really do need to have an understanding of these locations, particularly the critical habitat in the areas for the species and the changes in the distribution and habitat use. Of course, the population is increasing, and so as it increases, it is going to shift in terms of how it's utilizing these key areas. So based on these drivers, past Pender Bay research actually was initiated in 2006. So this was Deb Thiel as well as Two Moons Whale and Marine Research Base. So that's Andrew Bowles, who's co-author on this project. And they started land-based observations from a cliff. Following this, WAMSI and GGAC, which is the Gujar Gunyul Aboriginal Corporation associated with Two Moons Whale and Marine Research Base, then continued the land-based research as a citizen science program. The idea behind citizen science, of course, as we all know, is it allows for long-term monitoring at quite a cost-efficient way. It captures important information for management, and it improves conservation awareness and skills, and that awareness is critical as well. These data that were collected were used to examine factors influencing the timing and use of Pender Bay humpback whales. So this particular work that I'll present today is focusing on 2013, which is the very last of those years of that program. And the aims for the 2013 program were to estimate the relative abundance of humpback whales in Pender Bay, investigate the timing and distribution of the whales in relation to other variables, estimate relative proportions of adult females and calves and their timing in Pender Bay, and then also really think about those methods that were used and protocols that were used and how can we improve them, what are their limitations. Okay, so where? Pender Bay. We've got that. Cliff top, 34 meters. It'd be nice if it was a bit higher, but 34 meters, pretty good. You get pretty good sightability with that. When between late June and October, and how we discuss that, visual observations by trained citizen scientists using binoculars. So the location just at the red dot, that's the land-based station where the observers were collecting data from. Okay, of course with citizen scientists, it's a matter of sort of balancing out what can be done quite well and accurately by citizen scientists with a specific set of experiences and skills, and then trying to maximize the information that's collected. So that's what we did. And of course, we needed to think about how best to accommodate them. So of course, they do need to be as comfortable as possible. And for us, this was as comfortable as possible, which was this amazing rustic caravan that at least allowed for some shade. And what we needed to do as well was accommodate for variability in numbers of observers. So volunteers come, they get trained, they stay for a little while, and then they go, which is something really to consider. And then quite often there'll be only 2, and then suddenly there might be 3 or 4. So the area was split into sectors where this information and the number of observers could be recorded to be able to then use for modeling to correct for biases or at least test what biases there were. Of course, if you have 4 observers, you may be likely to see just a little bit more than if you have a couple of observers. Instantaneous scans were used. These were 5-minute scans, and they were done every 20 minutes. And basically, these were done in 7 4-hour shifts a week, and the shifts were either in the morning or the afternoon, and every attempt was done to try to balance these, and of course on good weather days. The information that was collected was bearing and distance measured. So this was literally using binoculars that have reticules and a compass in it. So again, trying to select something that's easy for people to use, especially if they have only a few days of training. The reticules allow you to get information on how low from the horizon the animal is, and then that information can be used to then work out or estimate a distance. An ethogram was used, and the ethogram was basically developed so that it was a bit simplified, again, to not make it too complicated. So, for example, breaches, anything that was like a breach, even a half breach or an inverted breach, that all fell within a breach. Other behaviors that were recorded for cues were blows, for example, fluke slaps, and so forth. Environmental conditions were measured as well, and again, very important for modeling to be able to assess what the bias is in the observations and ability to detect these animals. So these included Beaufort condition, so sea state, cloud cover, as well as glare. And also vessels in the area were recorded, and these were categorized in main groups. So the data analysis was done using several tools. One was Radar Tracker. So basically the information on the bearing from the binoculars and the reticules down is input into this software was developed by Hendrik Kniest at University of Newcastle. And this gives you an idea just on the left of how they appear. So basically it's able to calculate where the animals are in space based on those measures, and it corrects for the tidal change as well. And everything's presented in terms of 5-minute scans, and R was used to analyze the data and to plot the data. Okay, so for the first aim, estimate the relative abundance of humpbacks within Pender Bay. So the first thing was just to get an idea of what the effort looked like through time. So the effort was relatively consistent, which was really nice actually. So again, this is number of scans over date, so over the season. At the beginning, a bit of a rough start. Then generally sort of the 4 hours, you can see sort of that bar that goes across. Let's see if I can get it just here. And then sort of if the an extra hour was done, you get that top one, occasionally bad weather windows. The detection range, again, was really important to consider, and Michelle talked about detection range. And again, you can see here, of course, closer up to the cliff, you can see them, not like in aerial surveys where you have that blind spot, but of course you have a smaller area that you're measuring whales in, so you have that lower. And then there's sort of a peak just up between 3 and 4 kilometers, then with the drop, and so that drop's really important to consider. Okay, so the maximum number detected at any one time, which was in the peak of the season, was 32 individuals in 18 groups. A very, very rough estimation. So this is literally me just kind of in my head working out based on availability biases that have been estimated in the past, based on the detection function that we saw, is basically 1 whale per kilometer squared. Very rough. I would not set it in stone. However, it's important to get an idea of that. And it's important in thinking about that to understand, okay, well, what needs to be done next? The peak was in late August, which we can just see on that figure there. Okay, so how about timing and distribution of humpback whales within Pender Bay? So again, keeping in mind the lower detection range with distance. So here's our location of observation. It's going to decrease with distance. So all we can really think about, just looking at it from this scale, is how does this change over the area? So taking into consideration that decrease in detectability with range. And so what we can say is there is unequal distribution, particularly in the lower depths. So we know that we can't assume in an area like Pender Bay that there's homogeneous distribution. Therefore, in terms of thinking about correcting for the detection function, well, that assumption is violated already. And that's the reason why these analyses were not carried the next step. Okay, so no marked shifts in distribution in the different seasons. So these represent the different, months or periods over the season. And there's more distributional assessment that needs to be done. Okay, so thinking about, for example, sea surface temperature, which is really interesting that Michelle discussed this. So thinking about the association, and again, you can see the limitations in the data of sea surface temperature, which is again why further analyses weren't done. But what can be seen is just in this arrival period, there does seem to be an association of increasing temperature with increasing numbers. However, that then changes as the animals are starting to migrate south. So I suppose thinking about what stage of the migration or behavioral state the animals are in is important in considering the association with sea surface temperature and some of the other variables. So what needs to be done with this is really looking at multiple years to understand whether there is consistency and getting that really robust data to be able to do those analyses. Okay, aim 3, estimate relative proportion of adult females and calves and the timing of their use of Pender Bay. So calves were already present early on in the season, which is important to know. And then they peaked. So there are a couple anomalies here, but in general, there's sort of a more what might be expected that peak during the season in early September, just in this area here. In looking at the proportion, there are larger numbers early on. Of course, there are fewer whales, so that makes sense. And then as more and more whales arrive, of course, there are fewer proportion. But a really critical thing to note is that with the calves, again, 5-minute scans. There's not a lot of time to actually identify the groups and what's in the group. Normally, you have to watch them for a while, and then after a while you say, yep, been focal following this guy, there's a calf in there, I can see that. And these citizen scientists are amazing, but again, they're limited in their experience and skill. And so anything on calves here is completely underestimated. Aim 4, evaluate the methods and protocols for producing useful monitoring information in humpback whales in Pender Bay. So, as we know, citizen science provides valuable information, absolutely. And often it's the only way to get that long-term data set. However, what we always absolutely need to do is make sure that we're not interpreting past the limitations of the data. Also, it's absolutely critical to train these citizen scientists and really, really invest in that. Because again, if you have citizen scientists there that think they might have seen a calf and they don't know that, no, unless you're certain, you should not be recording it as a calf, and also what to look for to identify what a calf is, you'll be getting data that are lots of calves, for example, if they don't have that training. Very important. Also, recording all potential biases, including the number of observers, who they were, and also environmental conditions, among other things. Consider information that can be accurately recorded by citizen scientists, so simplifying information enough so that it's easy for them to collect, but at the same time is collecting critical information. And also thinking about techniques or technologies that make their life easy. Those binoculars gave us a rough idea of where sightings were, and they were very easy to use. Preventing double counts are absolutely critical as well. So really training volunteers to communicate with one another when they've got their sectors that they're watching, so that they're not counting the same whales in that border where their sectors cross over. They have to communicate as a team. Okay, Right, so conclusions. This study showed that the number of whales were consistent with high use area. So this is basically consistent with the Camden Sound Marine Park Special Purpose Whale Conservation Zone. It's an important area. Less than 10% to around 40% of groups were cow-calves, and obviously this is an underestimate due to the reasons that I gave you before. Limited visual range, scan samples, and limited experience. The likelihood is that the percentage of cow-calf groups are much, much higher. The highest relative sightings in waters were deeper than 10 meters, which is consistent with the tidal range. The use of the area is that of a breeding destination. In this particular area, there was no on-offshore shift, as in the migration locations. And finally, citizen science provides valuable long-term monitoring information. It also provides a critical role in increasing awareness and providing education and training. It has limitations, and we need to recognize this. So research recommendations. So the next steps at Pender Bay, continue long-term monitoring. It is very useful. It gives us an idea of what's happening over the long term, over the years. Estimate the density distribution within Pender Bay using systematic vessel surveys. So we know that it's heterogeneous. We can't make assumptions. And so it's difficult for us to interpret that information in terms of distribution from the land-based side. However, if we do systematic surveys on a vessel, for example, we're able to capture that. And investigate sea surface temperature and other oceanographic conditions and humpback whale arrivals over multiple years to determine their importance in predicting the use of Pender Bay. So for the bigger picture, so our update, our population update on humpback whales in Western Australia, the last one was in 2008. So we're almost 10 years on, so we actually need to do another update. The other thing is we need to estimate the proportion of the population and relative density in different breeding grounds, which is obviously what Michelle and Mark and Kurt and Mish and Kelly have been aiming to do with the work that they've presented today. We need to determine the proportional use and density of cow-calf pairs across areas. So in other words, really get a feel for how the comparative importance of those locations are and how that changes over time as well. Investigate association between breeding area density and abundance and oceanographic and climate drivers. As those change, then the selection of sites may change and certainly will, I imagine, depending on population size and the characteristics of those habitats. And then finally, based on all of this, update the assessment of critical areas. And I'll let you read through the acknowledgements, but most importantly, of course, are the amazing volunteers that put all their time into this and are very passionate. So thank you.
Thank you. We still have a few minutes left, so if anyone has any questions for Michelle or Chandra. Rob?
Michelle, the population estimate of 30,000 in 2008, they would put the population today at 50, in excess of 50,000, which will put it to in excess of 100,000 by 2022. Given that, 100,000, that's what it'll be if it stays at 10%. Just my observations are that all of these areas like Pender Bay, the whales are just going to be everywhere. There's so many of them that they have to basically be everywhere along the whole coast. Do you think it's a good idea to take the satellite imagery and put it somewhere where the whales are focused? Ningaloo, I was thinking, and do systematic satellite image-based photos of an area where we suspect we catch most of the whales going up and down, because we really need a good handle on how many whales we've got. There's just going to be so many, it's going to create problems.
Yeah. Yeah, I mean, that's a good question, Rob, and it's not something that we did go over in this study, because, as you know, it was focused in the Kimberley region. But yeah, there's a lot of talk about where is the best place to monitor, and maybe the Kimberley isn't. But we have a marine park at Camden Sound, so it's important to be monitoring that area, and where we think it's an important area for the nurse and females. But yeah, certainly I think Exmouth would be a really good place. You know, the animals rest there as well. And behind the reef, clearly there's some other activities going on and we're giving birth even.
Were you able to get quantitative estimates of numbers of whales with the satellite?
Yeah, so we were able to count all the animals in the image that we could see, but we can't really convert that count into an abundance estimate, you know, in the same way that you can with distance sampling. And clearly you don't really need to because you've counted everything in the sample. Whereas with distance sampling, you know, you're doing a survey that's meant to be representative of the area that you then extrapolate over. But of course, we can't take a satellite image of the whole Kimberley because that would be
But we
$1
could do a
million.
satellite. We could do
So
a
yeah, basically, as you said, you can use the satellite images, but you need to know availability bias and perception bias and account for those to be able to get the abundance. And as you're exactly saying, if you select a location off the Northwest Cape, great, you could do a population estimate by going through the migration, and then obviously the different question is the Kimberley. It's a really, you know, different question. Yes, exactly, absolutely. But it's about knowing what the availability and perception biases are, which is hard.
Mm.
And just relative to that point, you point out with the volunteers, one of the major issues is double counting between volunteers at the same time. But given that those whales are resting, what about the issue of double counting between shifts and between days? Because presumably a lot of those whales aren't actually moving.
That's right. So at least with the work that I presented, there's scan samples, and it's an estimate of the number within a 5-minute scan sample, and those scan samples basically for 5 minutes is counting all the different whales in different positions in that 5 minutes. So it's a snapshot in time. But as you say, then you know, extrapolate if you're going to count it all, that doesn't make any sense. It'd be a matter of doing photo ID. Yeah.
So that's why, exactly, so that's one of the issues with the monitoring thing that Chandra was talking about. We can't really use that for abundance because you can't do abundance with that because we can only say how many whales are in the bay at one time if you're counting the same whales in every scan sample. It doesn't really tell you anything actually about your population abundance.
Yeah.
I said, with that image processing, I don't pretend to be expert in any way in this, but with the footprints on the surface disturbance and some of those images, you can see the whales below the surface, and you know that some image processing type of thing could actually tell you whether they are whales, and you can start to work out, you know, how far down you can see them as well. And then probably include that availability, because when we're talking about sharks and things up here, is there's stuff that's done with the most sensitive that you can see sharks. If you want to know images of sharks below the surface, you can't see in disturbed water.
Mm.
So some of that stuff that is possibly worth looking at.
Yeah, the blue
other
spectral bands can see some way into the water, but they actually don't have the highest resolution. It's a panchromatic band that has the 30 centimetre resolution.
But you might be able to work out, you know, the underwater, one of the images I saw up there, you can see the disturbance after dive, but I'm pretty sure you can see the whale below the surface as well.
Yes, a lot of there's a huge discussion on exactly how to best measure availability bias, and it's been a topic of workshops, specifically this question. So estimates that I've done with Curtin, Mish, Jen, and Phil Boucher, we had quite high variability. It's the best estimate we could get, and it was based on vessel scores to work out how long they're down. Now more and more drones are being used to be able to go over the top, because again, you know, as you say, you see them some distance below the water. And so it's trying to understand to what degree, and then it's going to depend on the location.
Because we know they're up to, you know, they're something like 40, 50 foot long, whatever that is in meters, you know. And the other thing is, if the whales are just sort of sitting, and I remember this when I first did it last time, a very long time ago, but the hills are reef down there, you know, and it's actually just a couple of whales with the water breaking over their back, so different ways of that. The other thing I'm going to say is that Pender Bay bit, how, given that you were getting from 8 o'clock to 5 o'clock, and generally the high water's in the middle of the day, and you would have sampled across neaps as well as springs, and most of your mid-year when you got about a max 6 metre tidal range up here. The top end of Pender Bay with that green on your images, that dries right out on low water, so that they're not available to be seen there. And of course the other thing is that the Frenchmen, who were there in 1800, were very clever, and the extension of the system that's got the less speed islands on, they named it Baleen Bay for obvious reasons. There's the other thing for that is that we know from even that far back that generally humpbacks aren't seen further north than about 14 degrees, and people have seen that in recent times. So that goes back 200 years. It's just the number of whales that are there now. But that general pattern, because I wrote to John Bannister when I first went to Kimberley, he said you have to go and look here if you want to see what the humpback whales are out to.
Sorry, Rob, there's another question about that.
Yeah, just a quick question, Michelle. I'm just wondering, one of your biggest challenges is not so much determining your detection function, but I guess having a systematic way of comparing between years the detection function and therefore your abundance, because if you've got such a variation of whales moving in, staying, and moving out of an area, the timing of your observations is going to influence your potential abundance comparison between years. So if you've got a, and we see this on Barrow Island, for example, whales migrate through, you've got very few detections early in the season, heaps mid-season, few later in the season. So if you're comparing from one season to the next to see if there's ups and downs in population size, it's something that's worth considering in cross-year comparisons, which is easier said than done, I know.
No, it's the biggest problem with the data, as I said, that they all, because we got the data from industry, they have different objectives in mind than just generally monitoring the population, so we just had to get what we can out of it. But certainly, we can't say anything about the differences from one year to the next because the sampling was completely different from one year to the next.
I was just going to say on the observer bias, there's one particular observer who sees everything at 5 kilometres and then 4 kilometres of cliff. John Bannister's had the same problem.
Yeah, right. Yeah.
So, I know who it is. So if you've got the observer,
I do have the observers.
Yeah, so she's basically got, she sees everything out to 5 or 6 kilometres and then boom, she stops seeing it.
Yeah.
And the other issue is
so that might be cause of that as well, not just the fact that
it's
there's
just
around.
one observer's.
Yeah, you probably already have used Observer itself as a covariate.
I haven't, just because we don't have that for all, and I'm trying to compile everything. But yeah, it is in the data.
Yeah. The other thought I had, Rob, is with that idea of using the satellite images off of Northwest Cape. So with the aerial surveys, analysis used for population estimates, because we always get that super high variability. When we looked at 10-day intervals for aerial surveys, there was quite a lot of variability, which meant our uncertainty was higher. But when we reduced it to the 5 days, it tightened up a bit, which was really nice. So then I'm thinking, okay, the satellite and the cost, the imagery, and and then how often does it go around? So how often can we get it? Whether it's
Once a week, maybe. Yeah.
Okay, all right, yeah. That's just an additional.
So, is there any information on whether the lure and current determines where they migrate, whether they move further out so that they're not affected by the current, so to speak? If it's at a greater speed, do they move away from it so they're not swimming into the current?
Well, we haven't looked at that as a covariate. Do you think that there's some evidence of that?
I don't know, I'm just thinking if you're swimming a long way north and you've got a current that you're dealing with, would you move further out so you're not doing that, or as opposed to just bashing it straight upstream?
So it's actually comment on the cat. Yeah, the gap cat.
It does, so like tracking up and down the coast, and we've actually seen that in years where you've got quite a strong northern current, well, a weak northern current, the whales actually sit on the inside of that current, moving north.
Yeah.
Latest some entanglement stuff, the year we had a really large entanglement year was the year we had a very strong northern current, so it actually pushed across the shelf, which obviously pushed it quite a lot further and short close to the year. So some of the work we've done, the satellite tracking indicated that will go up to the inside of the northern current and then tend to come back down in the middle of the current, which makes complete sense.
So there's a relation with the entanglements as well?
Yeah, so the year when you've got, we haven't fully delved into it, the years when you've got a strong northern current, likely to get a greater entanglement rate because they're probably pushing further into the close and to interact with more whales.
When you've got a strong current too with the fishing gear, you'll find it will go underwater one way with the current, and then if there's a strong southerly, like the boats on top will have it going back up north again. So the ropes are not just sort of one way and a bit shorter, they'll actually be extended the length of it with underwater.
But the Frenchman also said, and Curtin have found this to be true, that you have to go out to 20 metre ice bath to start looking. When Curtin and Michelle and they both went up there and taken rubber ducks off Pender Island, that's what they found in 200 years. That was what was there before the whaling knocked the hell out of them. Mostly they're there, that little triangle out from sort of Copeland, Adele Island, back into Raft Point, Camden South. That's where you can see what was there in 1985, July, August. Yeah.
Can I just ask another question on the calf size? You've sort of changed from half size to 3/4 size. Can that be accounted for? I mean, it's something
It's not
I guess
something
not
that,
doing size, it's just there's the
Yeah.
definition of a calf, and that's obviously changed recently, so that
it's not something the observers measure, at least not in aerial surveys, maybe.
Not even, not from the cliff.
Obviously from land-based observations, no, it's basically the height of the blood, the behavior, and then when you see the back, you know what size it is. Yeah. From aerial surveys, you can obviously identify by, qualitative assessment in comparison to the mum, especially, and also just the proportions of the different parts of the animal, the head region versus the area, the rest of the area. And then the other thing is the definition of a calf and the size of it, and it's a funny thing. So I think this is Lynn's and my best guess of what has happened. So Michelle mentioned Lynn, who's one of her students. So we've been working together in Northwest Cape last year on this exact issue. And our best guess is that potentially in certain areas, there has been an assessment of what size calves are in those locations. But of course, a calf in the Kimberley is going to be a different size than it might be, down off of Northwest Cape and then over in Geographic Bay before it leaves. So a calf is actually anywhere up until around 10 months when it's back in Antarctica and actually becomes independent, it's no longer weaning from the mum. So it is going to vary, and I think what's been done is, perhaps, and correct me if I'm wrong in terms of the regulation, but perhaps an assessment of what a size might be in a particular location for use in that location. Yeah. But I think what's happened is it's been carried over to other locations. So it's a little bit, I don't want to say messy, but complicated.
Yeah, because we've put it into policy and then it's being applied to commercial operations who are then refuting it. So it's nice to have some sort of data behind it. It's not recorded the size of it.
Yeah, no, it's tricky, and the definition, the 50% size of the mother definition of calf that's being used, so that's a national standard, but that national standard is across all species of cetaceans, so it's not actually even humpback whale specific, so it's actually just a bit too general, and the refined information that we've got is that, well, it's not actually quite appropriate for a specific situation that we're dealing with.
It's just the commercial operators are asking for evidence, so that makes it tricky for us as a department.
Shouldn't Murdoch have that? They've been doing drone work.
So Murdoch and also the Irvine has got strict HDL photogrammetry. So both great.
And both of those are specific to the Northwest Cape. So again, like all the calf size stuff wasn't an issue for the Kimberley project, and it wasn't something that any of this research has looked at, but it's certainly of interest in the Northwest Cape area. Any more questions for our lovely scientists? No? Well, thank you very much for coming along today. I hope you guys all found it as interesting as I have, and let's thank our presenters once again.